Okay, here's my attempt at Newton's law with temperature for a body problem. We're going to find a body at 10 p.m. It's dead, and it's 75 degrees. The outside temperature is 50 degrees. 1 hour later, the temperature is 70 degrees. When did the person die? If his original temperature is 98.6, let's solve this using Newton's law. Okay, so I want to solve this equation. Here's the things I know. T of 60 after 60 minutes is 70 degrees. The outside temperature is 50 degrees. That's T of S. T of O, that's when I found it, was 75 degrees. I can now calculate, and the time of these three pieces of data is 60 minutes. I can now calculate, solve for K from this equation that I had up here. I solved it for K. Okay, there it is. Okay, solve for K. Then I took that T sub D was 75 when it was found at 10 p.m. T sub S is 50 degrees, and T sub O is 98.6 degrees, and I'm using the K that I just found. When I do that, I can find the amount of time that has elapsed since the body died. Okay, and I'm going to do this in MATLAB. Let's make the second half of this video. Let's open up a live script. We'll save it as we'll call it new death. New death problem. It's being difficult. There we go. And let's start with a title, and we'll call it dead body problem, dead body temperature problem. Okay. And let's do our normal okay, let's execute that. Okay, let's do a section break. T of after 60 minutes, I found the body. It was 70 degrees. After when I found the body, it was 75 degrees, but after 60 minutes, it was the temperature of the body after 60. Okay, the temperature of the outside for this problem, which isn't the same as the book problem, was 50 degrees. The temperature when I found it was 75 degrees. And those three pieces of information will allow me to find K. And then, of course, the temperature of the body normally right at time of death would have been 98.6 degrees. So I'm going to use the first pieces of information to calculate K in accordance with the formula that I've already derived on my piece of paper, which was -1 over that 60 minutes times log, boom, boom, and I've got T60 minus TS slash TO minus TS. And let's just do that calculation real quick and look at it. That looks pretty reasonable. Let's find, and this is the find K from the original data. Okay, and now let's go ahead and find the time difference. And this data is from one hour's differences. This is from using the temp difference over the 1 hour period. Okay, and let's find the time since the original, since it actually died, which now I use the formula that I derived earlier on the piece of paper. Time, whoops, and this is log like before. Okay, and now I've got T of O minus TS. So the TO is what I when I found it was 75 degrees minus the T outside, divided by T of the body minus TS. Okay, and that's going to give me my total time. Minutes. Let's put a okay. Nice and neat. And we can actually do that. And let's see. So it's been 178 minutes. So that seems pretty reasonable. But I had stated that the time when I found it was 10 o'clock. So in minutes, that would be 10 times 60. So time of minutes when found, okay, and then time of death, oops, will equal the time at time S1 of minutes when found minus the time that's elapsed. Okay, and then I want the time in hours. So the reason I fix is I just want I want how many hours have gone by, what the time is in hours. Time, death, 1. Let me just with 1. Divided by 60. Oops. See? Okay. Okay, so that's the time in the hours. Okay, and the last thing I want is the time in minutes. And the minutes will equal, and now I'm going to round. So it's time death 1 minus time in hours that I just calculated times 60, and that will give me, the remainder will give me just the minutes that are there. Okay, and I can see that my time of death was 7:01 p.m. I hope this helps somebody. Boy, that was 7 minutes long for me to type all that stuff in. I hope this helps.